Unit 7, Part 6. We've been over the distinction between form and substitution instance. In parts 4 and 5, we have gone through exercise 1 from the back. Make sure you can now do that you can answer those questions. You can say of each of those particular statements whether it is or is not of the form above the line. Right, that's great practice. But let's start working now towards proofs. In a moment, I will say a little bit about each of the rules and be giving you some suggestions about when the kind of situation in which those rules will be useful and some warnings about how to not use the rules and so on. But let me stress again, it is very much on you to learn the rules very thoroughly, do the exercises. I won't be doing any of them, that involve just doing derivations or filling in the derivations, some of those exercises towards the back, at the back. Do all those to work yourself up to knowledge of the rules, but your assessment will be, you'll be given actual proofs, I'll be given the definition in a moment, but given actual proofs where you're given a set of premises and a conclusion, and it will be your task to write down the set of premises like this, on a vertical line, putting the conclusion at the bottom, and what you'll be assessed on really is your ability to use the rules which are appropriate and apply to apply the rules in the context of a specific proof as you need to get to the conclusion. Right? That's how you'll be tested. Right? Actually giving a series of justified steps, right? Providing not only a derivation, but a proof that gets towards the conclusion, give you the definition of all these things in a moment, and that's what you'll be tested on. So what I will be doing in later parts is actually doing a few of the exercises at the back which are actually doing proofs. That's all I'll be doing, giving you sort of a presentation of the end state that you need to get at, right? So you do yourself the derivation questions and so on. But what I'll be going through when I do the proof exercises, where you're actually the later exercises from the back of the book, we're actually doing proofs. I'll be doing that, showing you the kind of thoughts you need to have in the order in which you need to have them. I'll be stressing much more the importance of working backwards, right? Much more than Klenk does, right? The method of working backwards is much more important than Klenk indicates, I think. So that's what I'll be doing. But it's on you to learn all the rules. It's a very necessary, but not a sufficient. It's a very necessary, but not at all a sufficient condition for doing well in this course to be able to state the rules, to have memorized the rules and being able to state them. Right? You also need to be very familiar with the application of them. Okay, so before we get into actually doing proofs, a few words on some of the rules. I won't be mentioning all of them, just going to say some things about them. First two you're introduced to are modus ponens and modus tollens, very, very often used rules. Right? Again, I've stressed you need to be able to think it in its generality. Given, what does the rule say? Given a conditional and also given the antecedent of the conditional, you're entitled to infer the consequent of the conditional. Okay? Second rule is modus tollens, right? These are two of the three horseshoe rules, right? Klenk introduces them, gathers them by the operators involved. Modus tollens is, if I'm given a conditional and also given the negation of the consequent, I'm entitled to infer the negation of the antecedent. Sorry, that's a pretty ugly negation. That should be not P. Yeah. Tilde P. Okay. Yeah. Pretty awful. All right. And as I stressed in, was it part 4, the first screenshotted part, you notice and be clear on the fact that negations are in the form here, right? The second premise and the conclusion are negations. So you will have made a mistake in applying modus tollens if the conclusion you derive is not a negation. If it's not the case that the major operator of the formula is a negation, right? Now, each rule can also be thought like this. These are the conditions for the application of the rule, right? The conditions for the application of the rule are that you have substitution instances of the two premises, right? So, question, when can I use modus tollens, right? What are the conditions for the application of the rule? When can I use modus tollens? I can use it when I have a conditional and the negation of the consequent, right? When those conditions are fulfilled, when I have those things, I'm allowed to draw the corresponding conclusion, the negation of the antecedent. Okay, notice how you have to be careful in the application of the rule. Okay, just thinking about modus ponens and modus tollens, if you were given just these two premises in an actual proof, 1, 2, can I use either of these rules? And if so, which one? Try pausing and answering. Okay, what have I got? Well, I've got a conditional. What else do I have? This is where rigor gets important. It's very important to be rigorous here. Well, what is this? It's not the antecedent of the conditional. So I can't use modus ponens here. So it looks like, I might think mistakenly, I could use modus tollens. I can't use modus ponens because modus ponens, it's conditional and the antecedent of the conditional. I don't have that. So it must be modus tollens. And what do I need for modus tollens? You need to have the conditional and the negation of the consequent. Question, answer this. Do I have the negation of the consequent? The answer is no. The consequent is what? The consequent is not E. What's the negation of the consequent? It isn't this, it's not E. Okay? If I'm going to use modus tollens, okay, a lot of the times, a lot of silly mistakes are made by not attending to negations, right? Here, you've got to realize that modus tollens, P or Q, not P. If this is my conditional, if this is the substitution instance of my first premise, my Q is not E, which means the not Q has to be the negation of not E, not E, okay? We have to be rigorous, okay? So if I had those two now, then I can infer, and what's the conclusion? Right? Now this is, watch this, this is how you complete a proof, this is how you do, you put down a justified step. It would be, it's the negation of the antecedent, that is, not A by conditional B, okay? I'm just going to read you the last few definitions from page 139, the list of definitions. Okay. A justified step, it's either a premise or else a step that follows from previous steps according to one of the given rules of inference. That's a justified step, right? The things you write down should all be justified steps, where you've got three parts, like I said, formula, rule, and the numbers, which are the substitution instances of the premises. Right? It's a mouthful that just means I write down this, that's not a justified step yet. I have to say, what's the rule? Modus tollens, M, T. Which steps are the premises? Well, here's just 1 and 2. These will be the numbers, right? When your proof is like 40 steps long or 20 steps long, it'll be 6 and 11, right? All sorts of different steps that you'll be pointing to as the premises of the rule. Okay, so that's a justified step. It's either a premise. Notice that a premise is a justified step. Every line in a proof has to be a justified step. The justification for the premises is prem, right? We actually write prem like this. Okay, prem. There's a long definition of substitution instance before this, I'll skip that. A justified step is either a premise or else a step that follows from previous steps according to one of the given rules of inference. A derivation is a sequence of justified steps, okay? A proof is a derivation, a sequence of justified steps, in which the last step is the desired conclusion. So a proof is a derivation, but there's something added to normal derivation. Derivation is just a sequence of justified steps. A proof actually aims for a conclusion. A series of justified steps, derivation, ending in a desired conclusion. What you need to get up to and what you'll be assessed on is doing proofs. You'll be given a list of premises and a conclusion, like I said, and you have to figure out how you're going to get that conclusion out of the premises. Like, where is it going to, how is it going to be busted out from the premises? What rules am I going to get there? What rules am I going to use to get it? What formulas do I need to derive along the way to be able to get this conclusion out? I'll be elaborating on this when I talk about working backwards, and you'll see it in practice. All right, so that's important. A quick remark about hypothetical syllogism. I quoted the general statement of it before, right? It's not as often used, you'll find, as modus ponens, modus tollens. Disjunctive syllogism is used all over the place. Be very familiar with that. Notice that it too, that form as well, has negations, a negation in the second premise. Given a disjunction, given the negation of one of the disjuncts, you're entitled to infer the other disjunct. It's a very intuitive rule, right? This or that, but not this. Oh, I'm entitled to infer that. That's all it is. This is, given two conditionals, I'm just making a remark about where you should attend to, what you should highlight in your thinking with regard to hypothetical syllogism. Given two conditionals where the consequent of the first is the antecedent of the second. It states the conditions for the application of the rule. Given that, you're entitled to infer a conditional where the antecedent is the antecedent of the first and the consequent is the, however they word it, consequent is the consequent of the second. Whatever. How does she work? Hypothetical syllogism. Given two conditionals in which the consequent of the first is identical to the antecedent of the second, you may infer the conditional whose antecedent is the antecedent of the first and whose consequent is the consequent of the second. Right? This one's sort of easy to see in symbols, but the crucial thing I want to point out to is it's this identity that you need to be looking out for. You need to always have your mind on how am I going to be using this rule? What situations will I be in when I will apply this rule? Well, right, you're going to have, if you're looking at your set of premises, you notice I've got a few conditionals here. Conditionals. Oh, look, the antecedent of this conditional here is also the consequent. That same formula, A biconditional B, or whatever it is, that same formula also appears as the consequent of another conditional. Aha! The condition of the rule of hypothetical syllogism is satisfied in my premises. I can make that move. I can derive the corresponding conditional. Okay, that's what you need. That's how you need to be thinking these. Okay, I'll elaborate. Be making similar remarks about simplification, conjunction in the next part.